So in this lesson, we're going to continue our conversation about solving two-step equations. Now, as we've already talked about in a two-step equation, we're typically going to add or subtract in the first step. And the purpose of that is to isolate, let's clean that up, is to isolate the variable. So in the first step, we're adding or subtracting. And the purpose of that is to isolate the variable, or more specifically, to isolate the variable term. So what does isolate mean? Well, to isolate means to get alone. So if we're going to isolate the variable term, the term with the variable, we're going to do everything we need to through adding or subtracting pieces, get the variable term all by itself on one side of the equal sign. And then after we move on from there, in our second step, we should now be facing the equivalent of a one-step equation. So in the second step, we will typically multiply or divide to solve for the variable. So step one will be to typically add or subtract a term as needed to isolate the variable. Step two will typically be to multiply or divide using inverse operations to solve for the variable. So in the lesson that or in the exercise that we did in class today, we were using cars and buildings, we're using smiley faces, which was meant to represent happy students and homework. And I think we were talking about the cost for pizza slices. So those were intended to play the roles of variable terms and constant terms. So what I like to do when I look at a two-step equation is to first actually label above each of the terms, whether it is a variable term, in which case I will mark it with a V, or a constant term, which I like to mark with a C. And that's going to help me to see what is already isolated and what I will therefore need to move to get the appropriate piece fully isolated. So when I look at this, I see, and we're going to work with this first equation, 9n plus 4 equals 22. Well, there's 1, 2, 3 terms. The first term is a variable term. It has a variable in it, and that term is known as 9n. So we're going to label a V above that. The 4, since it has no variable, is an example of a constant term. And it's equal to the number 22, which also, because it has no variable, is also referred to as a constant term. So I want you to think about this equation. It is a variable and a constant on one side, and it's equal to a constant on the other side. So when I think about what is isolated at the moment, I can identify that the constant term on the right side of the equal sign is isolated already. That's the thing that's alone already. So what I'd like to do to get the variable term all by itself is to send this one constant term, the plus 4, over to the other side. So that's essentially what we've been doing without really understanding the deeper meaning. When we've seen an equation like this, I think we would very naturally realize that to undo the adding of 4, we would subtract 4 on both sides. So to isolate that variable of 9n, we're going to subtract 4 on both sides. Now, many of you would cancel out, and you would now get 9n equals, and we'll do 22 minus 4, and the math on that should give us 18. So in that one step of adding or subtracting, specifically by subtracting 4, which happens to be a constant term, we got the variable term isolated all by itself. So when we move forward from here, we are now faced with a one-step equation. And that one-step equation now requires me to undo the multiplying that it occurs between the 9 and the n by dividing on both sides. So I'm going to divide 9n by 9. I'm going to divide 18 by 9. And now my 9's are going to cancel out, and I should get a nice clean answer of n equals 2. So you see in our final answer, we have the n all by itself. It's isolated, but it's fully reduced down to just being 1n instead of the 9n that it was. So our final answer is n equals 2. Now, if I wanted to do a quick check, I could do 9 times 2 and add 4, and I'll check to see if that equals 22. Well, let's see. 18 plus 4, does that equal 22? 18 plus 4 is 22 equals 22, so check. So my answer is correct. Okay, so the top 3 equations you see here, the remaining 2 of the 3 are very traditional two-step equations where we solve by isolating the variable term by subtracting or possibly adding a a constant term on both sides to get the variable term all by itself. So you can see my variable term here is going to be 4a to go along with the constant term that's on the same side, and it's equal to the constant term on the other side. So I can see that I will be moving this constant term to go join the other side to get the variable term isolated all by itself. When I look at the next equation, I see a constant term on one side, on the left side, and I see a constant term and a variable term on the other side. And the same type of thing is going to apply, where I'm going to take the constant term that is not alone, that is not isolated, and I'm going to send it over by adding or subtracting as I need to make it go join its other constant term so it's fully isolated. So I'm going to trust that these 2 equations here are going to be very straightforward equations. Those really are just going to be reviewed for you. Now, where we run into a little bit of confusion is now when you look at the next set of equations, you notice that there's a variable term on one side. Oh, but there's a variable term on the other. So my variable term is not isolated. And I notice on the left-hand side, I have a variable and I have a constant. Now, the reason why I ask you to use this notation is so you can clearly see what's all by itself. What's all by itself right now, what's already isolated, that variable term is already isolated. So what I want to do is to get the variable term fully isolated, which means this one over here is now going to have to go join it. So if we go back to the top of our notes, we said that in a one-step equation, typically the first step is to either add or subtract to isolate the variable term. The only thing that's going to be different about this is that we're not going to add or subtract the constant. We're actually going to have to add or subtract the variable term that is not isolated to go join the variable term that is isolated. So we're going to do that if this is a positive 5n. Remember that term is out front and it's implied to be positive. We're going to have to do the opposite of that. So we're going to subtract that on both sides. So we're going to subtract 5n here and likewise subtract it underneath its similar term, its like term on the right-hand side. Now what will turn out to happen here is my 5n's will cancel. And I'm going to get my constant term of 14 equal to, well, the result of whatever 12n minus 5n is. That's going to give me 7n. So the goal here was to add or subtract a term, which we did. We subtracted 5n on both sides to get to the point where my variable term is all by itself. And my variable term is all by itself. The term with n, my variable term, is isolated, is all by itself, separated from the constant term of 14. So from here, you should see that this is a one-step equation. And from here, it's just a simple matter of undoing the operation of multiplying that's occurring. So we're going to have to undo the multiplying, and we're going to have to undo that by dividing by 7 on both sides. So if we divide by 7 on the right, the 7's cancel, and I get n. And on the left-hand side, 14 divided by 7 is 2. So we should be at our final answer, except for the fact that don't forget that this is that special case where we have to flip-flop our answer. So the 2 is going to have to jump to the right, the n to the left. So we're going to turn this around and we're going to say our final answer is n equals 2. Now, if we weren't confident that was the correct answer, well, as always, we have the option of checking. So what's my solution that I'm checking for? I'm checking to see if n equals 2 is my answer. So instead of 5 times n, I have 5 times 2 plus 14. Is it equal to not 12 times n? Is that equal to 12 times 2? Well, let's start doing the GEMDAS, the order of operations. What's 5 times 10? I'm sorry, 5 times 2 is 10 plus 14. Is that equal to 12 times 2, which is 24? Well, what's 10 plus 14? 24 is equal to 24. We see that when we put 2 into wherever n appears in this equation, in this case in 2 places, we get a balanced outcome. So that tells me that n equals 2 is my solution. So I'm going to just get you set up on these last 2 problems, but you're going to finish solving these on your own. So by that I mean I'm just going to simply label either a C for constant term or V for variable term in each case. So let me see. Negative 18 does not have a variable, so that's a constant. 8h has a variable, so that is a variable term. And 14h has a variable, so that is a variable term. So I notice that I have a constant and variable, neither of those is isolated, is equal to a variable on the other side. So that's isolated. That's the one we're going to leave alone. This is going to go jump and join the other. So you'll have to recognize whether you need to add or subtract that 8h, and I'm going to let you work that through from there. So one more, I have 2y is a variable term. I have 25 is a constant term. I have 3v because of the variable of y is a variable term. I have my equal sign separating the two. I can see on one side of my equal sign that the variable is the thing that, at least to start with, is on its way to being isolated. So what I want to do as a result is move the other variable term over to join it. And again, we'll have to recognize whether we need to do that by adding or subtracting. So I'll leave that up to you. In either case, in both of these cases, when you're ready to solve these equations by adding or subtracting the appropriate variable term, you're going to then get down to a one-step equation, as we had here, and then it will become a very simple process of either multiplying or dividing to finish solving out. So that is, in a nutshell, solving two-step equations with a variable term on both sides. Very similar to the types of two-step equations that we've solved in the past. The only thing that's a little bit different is we're stepping outside our comfort zone by not adding or subtracting a constant term anymore. We're adding or subtracting a variable term now to get the variable term fully isolated. So when we come back to class, we'll be practicing solving both types of two-step equations and getting much more comfortable and familiar with solving both.